Hi, good afternoon, everybody. My name's Tony Cicada, and I'm from AWS, and I'm here with Sam Corzine of Fetch. Fetch is one of our premier D&B customers. I help out with the D&B, Digital Native Businesses segment over at AWS, and Fetch, of course, is one of our premier D&B customers over there. Anybody from Fetch here? Hello. Anybody from other D&Bs that might be out here? All right, okay. So digital native businesses, if I can switch my slide over here, at AWS, we define them as businesses that are born in the cloud. They're business to consumer focused typically. Also, they have a strategy that is highly dependent on data. And as a result, they have very focused data strategies. They're also businesses that have products that are either digital or physical, but with a heavy concentration on digital value. And let me go back there for just a moment. So the good news is that for folks that haven't evolved their digital strategy to the degree that most of our digital native businesses have, we have a new portion of our website, and you can see the URL over here. And what this provides is some guidance for folks that want to be able to organize their business strategy similar to what our D&Bs are doing, which is organizing the data strategy first, and then from there, innovating forward, and having all the connectivity and the capability to access, organize, curate your data, and build it deeply into your business model. So with that, I'm going to go ahead and introduce Sam and let him take over.
Thank you. All right. So the meat of this presentation is going to be a technical presentation about machine learning, both kind of on the modeling side, how you get models that sort of achieve your goals, and on the engineering side, how do you get those models deployed in the cloud, hooked up to your apps, all of that stuff. But before we do that, I'm going to give a little bit of an intro. Who is Fetch? I'm assuming all of you have already downloaded the Fetch app. But if you haven't, here's the quick 5,000 feet. Fetch is a consumer rewards app, #1 consumer rewards app. Users, when they're doing their normal everyday shopping, so if you're at the grocery store or at a local convenience store, you buy products and you can scan your receipts at the end of the shopping trip. If you've bought any products from a partner of ours, so we do business with large partners like PepsiCo or Molson Coors, those partners are running offers, you get points, you can redeem those points for gift cards. The whole pitch is to sort of like create tiny little moments of joy throughout your shopping experience. Have fun, save money is kind of the idea with Fetch. For like a quick glance at the scale of everything, every day, 6 million people open the Fetch app, 11 million receipts are scanned, 416 million in retail sales are captured, et cetera, et cetera. You can look at the other numbers. And that 11 million receipts getting scanned every day is like the core of what this presentation is going to be about. It'll be about the technical implementation that it takes to handle the fact that at this moment right now, there's 100 receipts a second coming into our system. Users are out all across the country scanning as quickly as they can, and we have to be able to handle all of that load and make sure that they're getting the points that they're expecting to get and that they're having a good experience with everything. Little context about me before we get into the technical stuff. I'm a lead machine learning engineer at Fetch. For a while, that meant I was the tech lead for our scanning pack, so the pack that actually makes the receipt scanning work. Now I'm working in a guild lead function, which basically means I'm responsible for looking across all the machine learning and data science projects at the company, trying to see what works and replicate those patterns across other projects. So you take something that like works in one place, move it to another. We don't really have a huge ML platform at our current stage. So the meat of how we like try to take our winners and replicate them is through this kind of pattern. And the presentation today is mostly, I think there's like 10 slides of actual content, and most of them are little ideas and patterns that I have liked in our ML projects and that I'm kind of working to try to replicate. along the way, I'll try to tell some stories about what the last couple years have been like for us and ground it a little bit more in that. And I'll try to save some time for Q&A at the end. We'll see how my pacing is. There'll probably either be like 30 minutes of time for Q&A or like 5. So, yeah. Great. Okay, so why machine learning? I pitched this already. Hundreds of millions of purchases are read from receipts weekly. So, like the core of Fetch's UX, if you open our app right now, there'll be a little button on the bottom of it that says scan. You click a button, it opens your camera, and you can take a picture of a receipt, and within a second, it will respond and say, that receipt has been processed. During that time, we have to go from what you're seeing over there, which is like an AI-generated picture of a receipt, to some structured data. So like, what is the store name? What is the date? What is the total? What were the products that were found on this receipt that the rest of our backend can handle and award points on and all of that stuff. Shout out to diffusion models for helping me with a lot of the pictures that you're going to see today. There's a lot of AI assistance and all of that. And then the other half of kind of like the way I see our ML projects is a lot to do with user profiles. So the whole idea of Fetch is that you can do kind of intelligent targeted marketing. So instead of just saying, hey, everybody gets the same coupon, you can tailor promotions to users that are exhibiting certain purchase preferences. So if you are in one industry and you really want to target people who buy a certain subset of products or spend a certain amount a month, we allow people to do that, and we're always kind of working on making that part of the business more data-driven as well. I know a little bit less about that, so we're going to focus mostly on the left side of the screen, but it's super important. I want to call it out. And this is our hypothetical user, Bob, who lives in Virginia, and he loves fries. He keeps buying all these fries. And so we're hoping to get Bob some points on fries going along here. Great. OK, so there's going to be 3 main chunks to this presentation. I'm going to like kind of set up a little bit more context and all of that stuff. Then we're going to go into engineering details, and then we're going to go into data science details. My colleague Alec, I think, described this presentation as like Sam's scrappy intro to getting ML models into prod. So it's a little bit of like a smorgasbord of you're going to see engineering stuff, you're going to see data science stuff, how we like to get our projects moving along. Great. So first and foremost, first who, then what, right? So we really believe in this concept of like the teams are the things that are by far the most important. They're the people that actually do all of the work. There's a healthy representation from Fetch here today. Makes me really happy to see a lot of the people that helped build a lot of this tech here to be a part of this with me. And I'd say 3 years ago, Fetch did not have a machine learning team. Actually, that document scanning that we just kind of gave you the high level of was kind of cobbled together using third-party parts. So the company had existed for a few years already, and we had sort of like been scraping along by trying to hook together things that weren't purpose-built for our business. And that was sort of seen as a huge limitation for Fetch as a business because, one, there's a cost factor to it, so we don't really have a lot of control to optimize all those processes. And as our users are doubling every single year, you have to be really conscious of the fact that, like, hey, the unit economics of this have to change at a certain point. And 2, we didn't really have control over a super core part of our product. So when a user scans a receipt, there's this sort of moment where things can either go really well or really poorly. And actually, when they go really well, they almost never notice, right? It's like a huge part of scanning is to sort of get out of users' ways. We don't want them to know that there's some algorithm running that's reading their receipts. When they do realize that, it's usually because the algorithm screwed up and wrote something dumb, and they have to contact our support. And for the longest time, when those dumb things happened, we had roughly 0 levers to improve the actual algorithm itself, which just meant, okay, we're going to try to get them a good support experience, which becomes really painful as you scale. So Fetch realizes we need to take this stuff into our own hands. And I think the leadership at that point realized, okay, we don't know all the details of how you build a giant document scanning pipeline, but we know there's probably going to be some machine learning stuff involved in it. And they went from having sort of a handful of data scientists doing kind of advanced analytics work to a machine learning engineering team and a data science team and a large group of people that were put together that could actually build this product. So in a relatively quick time, we went from a handful of data scientists to more than 30 data scientists and machine learning engineers. And a quick detail about our org structure. Fetch has an engineering concept of having packs, basically. So like you have cross-functional independent project teams. There's no true central data science team that sort of takes requests in and delivers models or anything like that. All data science and machine learning engineers are embedded on project teams, which actually ended up being really great for a lot of this project work because it meant that the people training the machine learning algorithms are right next to the people that are actually going to deploy them to the back end, that are going to like get the features into the mobile app. It limited a lot of the disconnect that can kind of happen there, and I've seen that happen in machine learning organizations. So this is where we kind of set the story. Maybe when I joined the company 2.5 years ago, we have no scanning pipeline inside. We've built this team. We're going to try to take a stab at building a machine learning model for scanning. Okay, so there's sort of 3 core sub-projects inside of that broader project that we're talking about here of building a document scanning pipeline. The first one that we actually tackled is fraud detection, right? So there's actually a natural incentive in some of Fetch's app for users to doctor receipts to try to get additional points. It's not a huge problem, but it's this kind of thing we want to catch before it makes its way farther into our system. So we started with like simple image classifier models and things like that. We're the first machine learning models that we got into prod. They run async after scanning. The performance requirements were a little bit lesser, just sort of trying to catch simple features. This stuff has evolved a lot, actually, since then in ways that I can't say in a public forum, but that's a huge, huge part of Fetch's business is like, how can we catch potentially bad actors before they've actually been able to redeem a gift card and they're at a store somewhere spending our money. From there, there's document understanding. That's the umbrella of what we call the scanning pipeline. A lot of people, when I say, I work at Fetch, it's a receipt scanning company, I do machine learning work there, they say, oh, so you have an in-house OCR. It's actually a lot more pieces than that. So every time a receipt comes into our pipeline, yes, we do OCR, but we also have to do text classification to understand what all the words on the receipt are. And we have a fancy graph neural network that does grouping on all the products. And that's kind of how you get from the point of like, okay, there's words. Like if you've ever run an OCR model, there's a bunch of words that come back at you. It doesn't say like a user bought some Cheetos or something like that, which is really where we need to get very quickly. So document understanding is the broader umbrella of those 3 projects together. And finally, product intelligence. So a crazy thing about Fetch is that users are allowed to scan receipts from any store in the country at any point. Like that's part of our promise to users. You don't have to decide, hey, I'm going to go to this very specific store because Fetch supports it. We're going to do a best effort pass at understanding any receipt that you give us, which means that we don't have an exhaustive product catalog that's like tightly integrated with a retailer that says, when you see this on a receipt, it means this, right? That it's actually these products. And so we've started putting a lot of work into building algorithms that can, at first one retailer, but over time, more and more and more, have a deep understanding of like how those receipts are laid out. When you see these words, they mean this. Because we can't award a user points unless we actually know they bought that one Pepsi, Diet Pepsi, 12-pack that Pepsi's promoting right now. You can't just say, hey, I saw the word Pepsi, here's some points. So I would say these are the 3 key pillars of the scanning project as they sort of built up. Moving forward. This is a pattern that we like to use for thinking about how you like kickstart a machine learning project. So here we mentioned Streamlit. For those of you that are familiar with Streamlit, it's a Python-based tool that helps you build full-stack demos. And I would say almost every machine learning project that you start as a company should start with some kind of like pretty end-to-end demo, in my opinion, before you even consider it to be a project. And it's one of those things, it might feel obvious, it might feel not obvious. But when I actually first joined as a machine learning engineer on our scanning team, before we even had models that were kind of compelling and could work, I thought, hey, I'm here to do automation. So the first thing I'm going to do is start setting automation pipelines up, right? And that ended up being really painful when we changed modeling strategies 3 months in, and me, Sam, had to go in and delete a bunch of Airflow pipelines that were sort of like a road to nowhere kind of thing. So I would say if you don't have a way to build a simple demo that can show end-to-end, you can put in, hey, here's my receipt content, here's this, here's that, please spit out what I'm expecting. You probably are not ready to really staff a team around it. 1 to 2 people should be able to do this kind of thing. You should be able to be, it doesn't have to be that fast. It doesn't have to be like meet your performance requirements, your scaling requirements, or anything like that. It just has to show, okay, we think we can do this. The model will get there eventually. A really good step from there is to sort of split up, okay, here's my Streamlit app, right? That's a good kind of full stack demo. Separate out backend components of that, which will set you up really well for the final step, which is that backend. So suppose hypothetically it's some fraud detection pipeline. You put an image into it and it says yes, no, I think this is fraud. We have a pattern really often. People can kind of get to this place where the Streamlit app that started the whole thing is still talking to the same backend that the mobile app is going to talk to, right? Except now it's just a client, and it's become like a much thinner view layer. I absolutely love the fact that a tool like this can help you go from like full end-to-end demo kind of hacked together, and there's a kind of streamlined process to split that up into something that you can run in production. So this is, when I talk about patterns we're trying to replicate all over the place, anytime I'm looking at a new ML project at Fetch now, I'm like, do we have a little demo that can just show me what it is? Can you deploy it internally? Can people play with it that have the domain expertise, all of that kind of stuff? Also, quick shout out, we released open source a Kubernetes operator for Streamlit that makes it easier to deploy internal Streamlit apps. So if you check us out on GitHub, Fetch Rewards /Streamlit operator, and hit that with a star or something, that would be awesome. I think we're really proud of that tool. And when people star our stuff, we get to do more open source and all that, which is great. OK, great. So now, assume that you're running your project. You've got your Streamlit app, you're feeling good about it, you're like, hey, the model's not great, but I think this can work, right? Like I think if we put 6 months, 12 months of work into this, we're gonna start to see the results that we wanna get. At that point, I tend to go a little split brain and say, there becomes like an engineering part of your project, which is there to deploy, scale the model, and integrate it with the application. And then there is a modeling part of the project that is going to take the model and take it from 80% accuracy, or whatever the demo was, to the 99% accuracy that we need before we can be in production. So we're going to split those up. First, I'm going to talk about some engineering patterns that we really like at Fetch, and then we're going to sort of double back and talk more about patterns for making your models better over time. Great. So microservice patterns. This picture, it's a pretty simple picture, but it's one that I feel like I learned via some pain, actually. And essentially, at Fetch, all backend services, well, for the most part, nowadays, are Go services that are super high performant, concurrent, all of that nice stuff. But when you start building machine learning applications, almost without fail, your machine learning library is going to be written in Python. And so you're going to have a moment where you go, what the heck do I do? All the backend engineers use Go. I have this like Python script. And people on the internet are telling me I should deploy like a Flask app or something to serve my Python script, because that's what Python is, et cetera. And it gets pretty confusing, like how do you split up your domains? How do you achieve all this stuff? So we are heavy users of SageMaker endpoints. They make it like super easy to go from a model that you've trained to something that kind of feels like a Lambda that you can hit with some arguments and get the response that you're expecting. But the models themselves, I mean, you're not going to see this in some of the demos, but almost all models, they're not going to actually map really well to a business domain, right? So if you have like a image classifier, and you say, hey, I've deployed this image classifier, like that's not something that you want to say, okay, this is a service and anybody at the company can now hit my image classifier. That's almost certainly going to set you up for failure. Because all the things we've learned about domain-driven design say that like, hey, let's map the boundaries of a team, the boundaries of a service to a key business element. And when I look at this pattern, I see that Go service talking to the rest of the world, saying like, hey, I'm the scanning service, or I'm the product intelligence service, and I do this. And I have a very high-level schema'd interface that people can use without having to know about machine learning. And then it can call any number of ML endpoints. So like I said, when we run scanning, 4 deep learning models get called all in 1 second, or actually often much faster, before anybody responds with anything. But that's all hidden behind the scenes. Even the other services at Fetch don't know about that, which means that we can swap new models in, add new models to the pipeline, kind of expand the way things work without having to change a bunch of service contracts. The stuff in the background there is going to change really quickly. It kind of ends up feeling like an RPC framework sort of thing. Like you have your library that is talking to all of these endpoints from the Go service, and then the Go service talks to the rest of the world. And then one other thing that is kind of a gotcha is that it can be tempting to do lots and lots of things inside of these SageMaker endpoints, right? So you're going to start saying, hey, well, we're going to do a bunch of post-processing inside of these things, right? I got to clean up all these responses before I send them back to people. And then you can turn into this slippery slope thing where like your SageMaker endpoint becomes an actual thing that feels like a backend service. And during the scanning rollout, we actually hit a point where we had a huge library inside of one of our SageMaker endpoints, and we realized we don't actually want to deploy this way because we, instead of that library, want to add another model to the pipeline. And there was a moment where we were serving prod traffic for, I think, maybe 5% of our users, and one of these models was calling another model from inside of that server, which is a huge performance issue because you want your SageMaker endpoints focusing on utilizing the GPUs to the highest possible degree that they can. You want to like kind of maximize the efficiency of all that stuff. And Python's not super good at concurrency, and keeping a bunch of connections open inside a SageMaker endpoint will cause your endpoint to scale really, really badly. And so all of a sudden we're saying, hey, we're in the middle of a huge rollout that's going to basically change a core part of how this product works. We have a lot of traffic hitting this thing, and we want to break out a third service from that. And we basically had to do a rearc during the middle of a large rollout. And I do not wish that for any of you. So big advice is to just say, hey, if you like feel that one of your model endpoints is getting too big, is starting to feel like monolith or whatever, and you're pushing more and more logic into it, split that out into something like a Lambda or a small endpoint, or if you can, push it into the fast backend service that will save you a few milliseconds kind of thing. Next pattern that I really, really like is shadow pipelines. So almost always when we're rolling out a machine learning model to do something at Fetch, we are replacing some kind of like heuristic process. There's some rules that people wrote to get something done. There might be a bunch of sort of hacked together heuristics and business logic that we've decided, hey, this isn't scaling to the amount of use cases that we want. But models can surprise you in many, many different ways, right? They're these sort of like black box objects to one degree or another. And when you go to deploy them, you might say, hey, I have my accuracy number that I'm feeling really good about. But until you've actually seen it run on a full kind of array of prod traffic and seen like the distributions of things that people are really going to send to this thing, you will end up being surprised. And so we've built this pattern into a couple of our services now that has the main Go service, that same thing that we saw that was talking to the rest of the world, forwards a long request that it's doing to a Kafka topic with a short TTL on it. And that thing gets processed by whatever the new thing that we're going to push into prod, hopefully next week, next month, whatever. And then that service, instead of responding like in a call response pattern, writes its predictions to a new Kafka topic, which allows you to do, one, some basic analytics on things that are happening, and two, prove out that you're going to be able to handle the load that you're expecting. You can do a lot of load tests, and there's actually some notes on load tests in the next slide, but there's almost nothing that will give you more confidence than knowing that your system has been handling prod load for quite some time already. When we were rolling out to 100% of traffic with the new scanning pipelines, we had already been handling 100% prod traffic for, I think, a month, which made it one of the most comforting rollouts that I've ever been a part of in my life. It was just sort of like, okay, let's shift. We're in prod now. Hopefully there's nothing huge that we missed, but we didn't have any crazy chaos scaling issues. Great. Okay, so a couple more notes about scaling with model servers. So I will say, first and foremost, request feels super long. So Fetch is a super performance-oriented engineering organization. We often talk about we want 10 millisecond servers. That's like something you'll hear very casually, which when I joined I found surprising. It feels like a low number from other engineering orgs that I have been a part of. But that is sort of where we like to set the bar. It keeps the app feeling really, really fast to users. You don't have this problem of like user is navigating through the app and waiting for some database call that's happening in the back end. But if you're running a deep learning model, and especially if you're running several deep learning models, there are a lot of these architectures that if you can get them to run in sub 10 milliseconds, you get a PhD or like $1 billion company or something like that. Like they're just slow. And so the reality is that you're gonna have to like change some parts of your architecture to handle the fact that you're gonna have more connections open than you're used to, et cetera, et cetera. An especially key gotcha is that almost all model servers have these hidden queues in them. So you can see behind that Go service, there's a server, and then there's a queue, and then there's a bunch of workers that run inside of it. When I was just getting started doing this stuff, I didn't realize that these queues were going to be everywhere. Those queues are there for a good reason. They're there to make sure that like you are getting requests into and out of your GPU as efficiently as possible. There's like transfer costs associated with that. There's a lot of improvements that you can get with batching when you are calling ML models. And so without fail, there's going to be a queue. It's going to have some defaults set on it for how many records to hold on to and how long to hold them on or hold on to them for. But on the left here, you're seeing what I found to be an extremely confusing and cryptic load test when we were gearing up for our rollout, which is basically 3 consecutive different levels of traffic we're sending it. And you can see that the RPS tops out at about the same point in the second and the third run, but the latency just kind of doubles. And that is the fact that requests are just hanging out in a queue, right? So the throughput of those workers is some basically fixed number. There's a number, you can find it for almost any one of your model services. But the service will happily continue to accept requests, and it will just get slower and slower and slower until you run into some config on your model server that just kind of like pops, and then the whole thing falls over. So the good news about that is that services like SageMaker have pre-built in autoscaling policies for requests per second that will almost always be a better sort of rule to do autoscaling than if you just try to do like CPU or GPU utilization or something like that. Because there's sort of this number that if you're at it, the instance is working at maximum capacity. If you're over it, things are going to start backing up until the thing goes kaplowy. And if you're below it, the thing's not getting used well enough. So can't recommend enough. Do autoscale by request per second unless you have a very, very good reason not to. Awesome. OK. As promised, now we're going to switch back to you're running models in prod. The engineering, we're going to assume, for more or less is sorted out right now. But the model actually has to be good, right? It has to say the things that we're expecting it to say, and we send a broad variety of data to it. So let's talk about modeling. First and foremost, the most important thing you can do in any machine learning project is figure out your data. It's kind of a platitude and a thing that people are already going to tell you. But the reality of it is that when I look at our machine learning projects at Fetch, without fail, getting a good training data set that actually is reflective of your domain is going to be the big kind of unlock. Especially as pre-trained models get better and better, you can often take an off-the-shelf pre-trained model and just like fine-tune it a little bit and get your domain adaptation. But without the data, you're stuck, right? You can't take a model that does one thing and make it do another thing. I will say, if you're still in that Streamlit phase that I showed in the first slide, where you're like, I don't know if this is going to work, unless you're at a huge company, you probably don't want to engage annotators right away. That's like a huge thing to get started. There's money that you're going to have to sink in. There's a lot of time that's going to go into that. So almost every successful machine learning I've seen at Fetch started with a really clever idea for a way to kind of like scrape together a data set that looks like some mock version of our problem. And like for tasks that are kind of like NLP or text flavored, that's a lot of times like a regex or some clever rule you have about maybe layout of receipts. Maybe if you're training a fraud model, you have a good idea to get like a reasonable guess for that these receipts are probably fraud, even if I don't have time for somebody to look at every one of them. And taking a pre-trained model and fine-tuning it based on your scraped together data set is like the best way to get a POC. If the model kind of adapts when you give it a little bit of hacked together data, it will almost for sure get better as you start giving it more and more high quality data. So that's kind of your requirement of like come up with one clever idea before you get going. That's sort of the litmus test for whether or not the project is likely going to pan out. But you can't get all the way there based on heuristics, because if you could, you would just run those heuristics, right? So we need something that is better than whatever clever rules that you've figured out how to write down in your code base. From there, you really have to engage with annotators in one way or another if you're doing deep learning projects. There's a lot that goes into figuring out whether or not to do that internally or externally, and exactly the processes that I will set up for that. But I can say that it's an extremely sort of process-oriented thing inside of an engineering project. So instead of being like, hey, we're programmers, we can just hack together something really quickly, and then if we hate it, we're going to undo everything, you know, like a long day, and just kind of like refactor the whole project and change how everything works. That is not how an annotation team is going to see things. If you change requirements every day, that's going to cause really long cycles that are going to take weeks, if not months, to keep changing things. That being said, it's super important to get annotation requirements right. So if you're kind of still trying to figure out what the problem exactly is that you're solving in your business, figuring out how to get your annotations is going to be like where you actually figure out what the problem itself is, right? So what I will say is, if you already got your demo, you already feel good about your modeling approach, engage with annotators early, and then as early as possible, engage with stakeholders and find little wrinkles that you might have missed in your requirements and all of that stuff, because it will be way easier to change in the first month than it will be 12 months into an annotation pipeline. One example from the scanning project I worked on, we thought we had gathered all the requirements. We said, like, people are going to need store name, people are going to need total, people are going to need tax. And then we realized there was a couple extra fields about payments that were critically important for certain parts of our business that we had completely missed for the first 6 months of annotation until we were like ready to go into prod. And that is not a good feeling, because now you have many, many thousands of fully annotated pieces of data that are sort of by definition wrong now, because you said they were something else. If there's some class that you forgot from your hierarchy, if there's some edge case that you forgot, the fact that you forgot that means that not only is your data missing something, your data is telling you that actually those things are all something else, whatever the thing that you told them they actually were. And so, I mean, we're still dealing with pain of that to this day, of, hey, there are certain fields we would love to have added that we missed. And so now, instead of just being like, let's just add them, let's just change a line in a document, we have many, many thousands of receipts that have to be reworked. And then if you get it wrong, then you have to be reworked again, which is not fun. If people want to be focusing on training cool machine learning models and deploying them, time you spend undoing a bunch of bad data decisions is not the best way to be spending that time. So that's all I'll say. Get it in writing. Write out a requirements doc. Here's how you annotate these things. Here's how you explain all these tasks. And then try to iterate early. So as the first versions of the model are being trained, really, really keep a good eye and make sure that you feel really, really confident about the way to describe your machine learning pipeline. Great. So shadow pipelines round 2. Let's talk about analyzing the predictions that are coming out of your machine learning model. If you have a model, there's almost always going to be some accuracy number that spits out of the training script, right? So maybe your model is like a text classifier, and it says, it looks at a piece of text and it slots it into some predefined list of classes. In the early stages of a lot of our projects, we get a model that seems to just be kicking butt. It's like 99% accuracy, it's nailing all of these cases, feels really good on all the data that we held out, and we're ready. Let's go into prod. We're ready. It's perfect. This is way past our accuracy requirements. The scale that Fetch works at, again, 100 million receipts a week, means that there are just, I want to say too many to count, but there's probably a number. There's a ton of edge cases that you didn't catch in that training and test set. So when you're doing your shadow pipelines, whatever baseline, if that's the heuristic business rules, if that's the cobbled off the shelf thing, do distribution analysis to say like, here's what the crappy thing we have but is running says, and here's what the new better thing says. And if those things disagree by order of magnitudes, something bad is happening. You can have 99% accuracy and still see an order of magnitude difference when you're actually comparing prod traffic. So like an example we have, I think when we were rolling out some of our scanning pipelines, we were just doing simple like stats on what percentage of time are we seeing certain retailers. And I think even though we were doing like 99% accuracy on our store names, we were seeing in the data like 50% decrease in McDonald's receipts, which is extremely unlikely, right? Like people aren't stopping going to McDonald's. People love McDonald's. So we have to look into that, which is our handy dandy investigator on the right here, who is looking at an individual prediction. So you've zoomed out, you've said, hey, there's something very weird in our distributions. Now zoom back in and say, okay, where the systems disagree, try to find those places, and those are the real business problems that you need to squash. And that is like the crank of every ML project that I see. It's get something predicting something, look at the places where things look weird, drill down into individual predictions, squash the error, most likely by getting something fixed in your training data, or getting more training data, or changing something slightly about your model. I think this is, last but not least, constant experimentation. So I will say Fetch was a software engineering still is a software engineering organization, but started investing a lot in machine learning. And I think we had to really get used to like the different workflow that happens when you're working on an ML project. Software can be a little unpredictable, right? So I have this ticket, I thought it would take 2 days, it took 4 days, everybody freaks out, it's horrible. But with machine learning models, like there can be a month where nothing really gets that much better. And it's because like people are doing experimental work, trying different ideas, looking for a big jump in accuracy. And that can be very hard to communicate in an organization that's not used to that kind of workflow. So I will say, think kind of early in terms of like, how am I going to set up the workflow for my data scientists to be able to record all of the experiments they're doing, and at least show, hey, we tried this, and that, and they didn't work. And that's okay, they didn't work, but like, we're working on it. These are the ideas, these are what we're enumerating. There's a lot of really great experiment tracking software out there. MLflow, we use Comet now inside of Fetch to track, hey, I did this training run, here's the score I got. And then you can write pretty minimal little documents that say, here's the thing I tried here, here's kind of why I thought it would work, here's why I think it didn't. And that kind of communication pattern can really like map back better to an organization that might not be used to the concept of like, I have a bunch of scientists and they're thinking hard about stuff. Conclusion, there's a couple more slides, don't clap yet. So now we have 4 different project teams running machine learning models in prod. There's about 10 ML models running. Every time you scan a receipt, 4 models run in the hot path, and then I think 4 to 5 kick in within the next second. And it's been an immense amount of work to get there, but we're super proud of it. We are, for the first time, I think in Fetch's history, in a position where when people come to us with like data problems, we feel like we have really solid levers to fix that. And so if a partner is saying, hey, I want to run this kind of promotion, or hey, this thing looks busted, instead of just being kind of, oh, we'll throw up our hands, there's nothing we can do about it, we have all the pieces in place to quickly turn around new models, quickly adjust what we're doing. It's been a huge unlock for us on that part of the business side. And finally, where we're going. So the scanning pipelines have been huge. I will say where a lot of like the sort of big future-looking stuff for Fetch is right now is leveling up, I think, personalization, discovery, and recommendation systems. The amount of insight people give us into their purchases is kind of incredible, and we really strongly feel that we should have maybe the best recommendation model in the world. If people are telling you every single thing that they buy at the grocery store, the least you can do is have a decent understanding of what they like and make sure that you're getting them offers that bring them a lot of joy. And so taking the patterns that we've found from the scanning teams, moving them into the RecSys land is a very exciting lane of work that I very much hope re:Invent will have us back next year to talk about, something like that. Stateful ML services, lots of investment into vector databases is happening right now. We're trying to figure out, okay, all the patterns that I just showed you sort of presume that your model is like this pure function that takes in an input and spits out an output. But we want to be able to do a lot more search-powered things with our models. And so figuring out how to make vector databases work has been some really interesting work. And finally, generative AI. So I didn't talk a lot about generative AI today. I'm assuming you guys have already heard plenty about generative AI this week. So I will say, we actually are already running a small generative model in prod. It's very hard to get a generative AI model to run on 100 million receipts a week. It's both expensive and slow and a bunch of other terrible things. But they're really good for some one-off use cases that you don't want to do some of the heavy stuff that we just talked about. So like getting an annotation team, sometimes a little prompt engineering, you can get away from that. So we have some one-off data tasks that we use inside of our business that we want to just say, hey, we're not going to push this into the core hot path models, but there'll be some async flows that we'll use to parse extra data. So that's all looking extremely promising. It's sort of like augmenting our core ML pipelines. We're happy with the early results we're seeing.
Thanks, Sam. Big round for Sam, please. Also, if you have a moment to fill out our survey, that'd be great. Much appreciated. Thank you, everyone, for attending.